Hi, we are Voltran Rover team and I'm the captain. Our main goal is to contribute to the Turkish space mission.
We divided into three groups to work more efficiently. These groups are electronics, mobility, and robotic teams.
Hello, I'm responsible from electronics. At the control center of our system is the Arduino Mega. We provide wireless communication with the robotic arm with the Analog module. We use GPS for positioning, IMU acceleration for balance, and we have motor drivers for main motors, load cell, and robotic arm.
We also designed the PCB layout using EasyADA. To separate the power and logic circuits, we implemented a hybrid structure using PCB and a PDB.
Hello, I'm responsible from robotic arm and general mechanics. We used 5 degrees of freedom on our robotic arm. Also, we used stepper motor with planetary gearbox on base to prevent step loss. And we printed our gripper from TPU filament to increase grip.
Hi, I'm responsible for drilling and lossless system. This mechanism mounts on using a 12-volt 300 RPM motor and rack and pinion system, while another 300 RPM motor rotates the drilling head. A 5 kg load cell measures the first penetration for the estimated compaction. The system combines control distance with rotation.
We developed a unique hybrid mobility system for our Rover, featuring a custom joint double wishbone independent suspension. To ensure stable driving, we utilized Ackerman's steering geometry to minimize tire slip angles. The drivetrain employs a lightweight pulley belt mechanism instead of heavy gearboxes transmitting torque via 90-degree twist. This enables instantaneous transitions, Ackerman steering for general transit and tank mode for zero-radius turns in confined spaces. This robust design ensures high mobility across challenging terrains.
I'm responsible for autonomous system. The pathfinding, navigation, and location tracking are done with hardware using GPS and accelerometer. While our rover goes to defined points, it uses OpenCV library to detect argo tags. The light from the camera is processed on Raspberry Pi 4. Then the electric tags ID is saved to an SD card with the current position and rotation data. Our team aims to return the moon base by following the same path vectors, and we are continuing to work at maximum performance to ground these tests with the full points.
Hello, I'm responsible from science mission in the team. We have planned gauging the density, moisture, and pH with essential sensors. We regulated especially a system that is suitable for working indoor. Additionally, we have been planning the light spectrum by an RGB sensor. We will see that values on our monitors after we process them in our microcontrollers such as Arduino and Raspberry Pi.